page is this on? Page number 600. Yeah, at the top of page 688. So we draw a space for each decision, and we put the number of choices in each one. To try to write this mathematically, they say if there are n different objects in one set and n2 different objects in a second set, then the number of ways of choosing one object from each set is n1 times n2. They're saying you have two different buckets to choose from. In the first bucket, there's 10 different things. In the second bucket, there's 8 different things. You get to pick one out of each bucket. So you have 2 decisions. How many choices did you have in bucket 1? 10 choices. You could pick anything out of bucket 1. How many choices did you have in bucket 2? I said you had 8. There would be 80 in total. But sometimes when they write something out, this gets a little bit confusing. But if we break it down to something simple, we're going to draw a space for each decision we need to make, put the number of choices in each of those spaces, and then we can figure it out. So if we go back to the first example here, a fan has 3 settings: off, low, and high. And you've got these set up in your bedroom so that you can have like a different windy experience every time you go to bed at night. Right? You can turn them, if you want like a stormy experience, you turn all 3 fans on high. If you want it calm with a light breeze, maybe 1 is off and 2 are on low. So these are different possibilities. How many different windy experiences could you go to bed to if you had these 3 different fans? Well, using the fundamental counting principle, you have 3 decisions to make. How am I going to turn on fan number 1? How am I going to turn on fan number 2? How am I going to turn on fan number 3? And each of them has 3 settings. So you have 3 choices for the first fan, 3 choices for the second fan, and 3 choices for the third fan, giving you 27 choices in total. Now, if you had to list all 27 of them, I'm going to show you a systematic way you could do that. Okay? And the systematic way, and it's used a lot in probability and counting, is something called a tree diagram. For your first decision, your first choice, which was fan number 1, we draw 3 branches. Decision number 1. And it could be off, it could be on low, it could be on high. That's fan number 1. Then fan number 2, there are 3 choices off each of these. Fan number 2 could be off, low, or high, off, low, or high, off, low, or high. And then you get to fan 3, and there's 3 choices off of each of these. Off, low, high, off, low, high, off, low. Oh my goodness. So you can see why listing them isn't necessarily the nicest thing to do, because there's going to be 27 of them. Like this first one, all of them off, ooh. And the second one, O-O-L, ooh. And you've got a bunch of those, all different choices, right? You want a little bit of a funny night, you could do this one, right? And we could list all 27 of them if we wanted to. But isn't it nicer to be able to do those spaces and put the numbers in to count that there's going to be 27 very, very quickly? Oh yeah, I've got actually quite a few for you to circle. 3, 4, 6. 11 and 12. And I'm actually going to give you 5 minutes to try some of this. So this unit, every single question is going to be like a unique word problem that you're going to have to read and decipher and figure out how it's going to work. And right now the word problems are super easy because I've taught you one strategy. So what do you think you're going to have to use? The only one strategy that you have. What's going to happen in this unit is that we're going to develop like 5, 6, 7, 8 different strategies. And then you have to figure out which strategies you're going to use in each